Hi, my boys and girls, and also the other learners on the other side. We are all welcome. Right, so we are here for in the second discussion. That's the second lesson of the new topic about the chord properties of a circle. Right, so be part and parcel of this discussion if you have not watched the previous video. So please go to the link down here where you need to watch the video that we had and see what we will have today. Because what we have today is a carry forward of what we did in the previous video. Please, you're encouraged to do so. Right. What is it that we have now? Simple. Right. It is just an issue that is related to what we discussed previously. Remember, we were introduced into the first chord property of the circle, that is in summary, which says that a line drawn from the center of the circle, like center O, and if this line, if it happens to be perpendicular to the chord, look at this, or to chord MN. If this line, or defined as OD, is perpendicular to the chord MN, it means this line is there automatically going to bisect the chord. Meaning to say, if OD is perpendicular to MN, simple way, it means MD should be equal to what? ND. Simple as that. And the converse of which it is true. Meaning to say, the moment we have got D here, you can define the D just like the midpoint of what? MN. So, what it means that if we have got a line joining the midpoint of that chord, which is D in this case, that's just like now the opposite or the converse of what I said earlier. And this line is also joining the center. What should you expect? It means this line should be perpendicular to the chord. Meaning to say that angle should be 90, the other one should be what? 90 degrees. The knowledge of which, let us see how we can use it into solving the problems. Right. With me, I have two examples. As at the end, I may ask you to write a particular exercise based on what we are going to discuss here. Right. So now, what we have there is just a matter of asking us to work out the value of the radius in the first question, given the information such like a chord of a circle is 10 centimeters long and is 12 centimeters from the center of the circle. What is the radius of a circle? Right. We all know that a circle will have all those variables, the center, the radius, as such. Right. So that's it. So what we're going to do here, if we are there in attempt to work up the value of the radius or any dimension or say length in the circle, the first thing, as I said, please draw the diagram of your reference. So it should be exact in order to understand what is it that you are supposed to do. So in this example, we have a diagram like this one that is there summarizing the whole statement here in this question. A chord, it means I have to draw the what? The circle first, like this one here. Look at this. Right? With a center, O, the top of a chord. So it means my chord will go like this. That's my chord. Name it AB, or any letter of your description, you can use it. Right, so they say a chord of the circle is 10 centimeters long. It means a distance from A to B is 10 centimeters. That's what is referred. And it's 12 centimeters from the center of the circle. What it means here, a distance from the center of a circle. When this one is mentioned always in the question, expect that line to be a perpendicular distance. You can't have a slanting line representing the distance, not at all. So when they talk of a distance from the center to the chord, that obviously should be a perpendicular line like this one here. Look at this one. So this line, or I'll write this one as F. This point here should be F, but the distance of A to B is 10 centimeters. So OF should be perpendicular to what? AB, because it is the distance from the center of the circle to the chord. And that line is given as what? 12 centimeters. Right. Now, what is the question? They're asking us to work up the value of the radius. Right. So what you do here is just a matter of drawing that line that represents a radius in this circle. So you are free to draw a line from the center to any point on the circumference. Yes, it's the radius that is referred. So one can draw it like this one, no problem. One can draw it like this one, no problem. But now, when you are drawing, or else you are adding information in the diagram, try to come up with the diagram in such a way that you should be assisted later. It'd be like when I've drawn like this, what is next? Because if you just draw it poor like that, yes, maybe a light track, but at the end, it'd be like you are stuck somewhere. So if I draw a line like OM, like that, yes, OM is the radius. So it means the question here is asking me to work up the value of OM. But in this case, how do I find the value of M? Right, so an intelligent student will always be able to think that to say, ish about finding the length of a side of a particular shape. When was it discussed? So that is the starting point. So what were the ideas attached to it? So that knowledge, you bring it here again. So like in your case, you'll be able to see that whatever we did in the past, there's a certain concepts about the triangles where we were working out the values of the size of a particular distance. So like here, once we have studied, we found that what we have been doing here, even the proof themselves, we were able to construct some triangles, and out of it, we were able to come up with the variables of our interest. So in this case, it means that knowledge should come into your head. So it means now when you're going to draw the radius, it should be in such a way that you have to produce a right angle triangle. Right, so here, instead of drawing like that, I'll draw it this way. This is my radius, so that the whole diagram should look like this, with a triangle inside. And M lies like, when I have got a triangle like this one, I will know that this one is perpendicular to this, then here this is 90, then the resultant triangle here, it will be a right angle triangle. So that my interest is at least to capture the knowledge about Pythagoras theorem. Because I know it's about Pythagoras, that they are trying to calculate the values of the sides of the triangle. So it's just like a matter of thinking and reasoning. How do I produce this like that? If I do like this, is it going to help me capture the value of the variable? No. What if I do like that? Like that. That's better. You have to think, because maths is about logic. You never always have something that is direct. So this is the way a diagram will look like. So by the question itself, it means we are asked to find the value of OB as such. Right. So let us take the step into it. So what you do here, since you have come up now with a triangle which is right angled here, you can mention it here like say, in triangle OFB. You can even draw the sketch of which. Just depict that part of the diagram that is of your interest. Leave the other parts. The distance from O to F is given as 12. That's what it looks like. And the distance now you'd like to find is the distance OB. But if you decide to use in Pythagoras theorem, you always remember that you need to be given two sides. Then you can find the value of the third side. Without it, it will be very impossible. So like here, I want to find the value of OB. I have this one given as OF, which is 12. Now what is there? What come what may, I have to find the value of what? FB. Then the value of OB will be found. So what is here? I'll need to work out for FB because it's not given. Right. So I'll come to the diagram. Based on the logic which I've just learned in the chord properties of the circle, we have seen that once AB is connected at this point here by a line which is perpendicular and starting from the center, it means AB is going to be bisected. So what it means here, it means the distance from A to F is the same as distance from B to what? To F. Right. More like FB is half of AB. Right. So it means if this is 10, this one must be 5. Right. So here we're going to write that statement. How you're going to find the value of FB. You come here and write like this to say FB is equal to half AB. You give a reason there. What reason? You just write the brief to me to say OF is perpendicular to what? AB. That's the reason that has made us to have that. Based on the proof in the previous video. So if that is the case, then substitute where I've got AB just like what? The value of AB, which is 10. You multiply by 10. And what you get there is what? 5. So it means the distance from F to B is 5. That's the way we do. So you apply the concept, it goes like that. Right. Now, having done that, what else? So you come and write by Pythagoras theorem. If this one fails, I have to sit down and think another way around. Right. So now, how does it go? It means I have now to state the Pythagoras statement. Right. So how does it go again? The statement I think you have mastered now by just the discussions. To say that the square on the hypotenuse side is the sum of the square of the other sides. So you need first of all to identify which among the three is the hypotenuse side. And that one has to be squared first. Then it's also related to the other two sides upon squaring. So the side that is opposite to the right angle is the hypotenuse side. So that side should be squared up. You have it like OB squared. That one is equal to this other side squared plus what? That other side squared, like that. So what you have here, it will be like OB squared is equal to 12 multiplied by 12. It gives us 144 plus 5 times 5 give us 25. When you sum the two values, the result you get is 169. So it means OB squared is equal to 169. Just to find the value of OB, that should be the square root of 169, which gives us what? 13. So our value there is 13. So it means you conclude here to say, therefore, radius is equal to what? 13 centimeters. That's all. Fine. If you can look at this one, I think you'll be able to enjoy it. That say this theorem is really just very friendly, and it is really going to be used now and again. Each time I've got problems that related to the what? Chord properties of a circle. Right. So here, let me also emphasize here. A square root of a number is not always positive. It can be negative at times. Right. Not necessarily at times, but it is positive or negative. All of that, in this case, whatever information you have here is about the variable that cannot be negative. That's why we have opted only to choose what? Positive 13. Right. Can we now go to the last example, which is question 2? Right? Question 2. For question 2, it talks of a chord of a circle is 9 centimeters from the center of the circle, and the radius of which is 12 centimeters long. Can you find the length of the chord? Leave your answer in simplified side forms. So you see now, that topic we discussed in that video when discussing about the word irrational numbers. Here it comes, more than the application of which now taking the chord properties of a circle. Let's see how this one will go. As usual, a diagram first. Here's my diagram. A center O. What does the question say? A chord of a circle is 9 centimeters from the center of the circle. So it means we are given a distance from the center to the chord. A chord 9 centimeters from the center. So it means your chord will be drawn like this one. Name it NQ. A distance from the center to the chord is always a perpendicular distance. Name it OD. So it is 9 centimeters, like that. Then you go on. Along the statements, after that one, you have got this statement to say the radius of the circle is 12 centimeters long. So as I already discussed with you previously, to say when you are going to indicate the variable representing the radius, draw it in such a way that it should come up with a triangle that should help you to work out the other side. Right, so here my radius will be drawn in this manner, or else you can draw it from O to N, no problem. So that the resultant shape should be able to have a triangle. By the line from the center to the chord, the triangle should be right angled. So this one will be named as 12 centimeters. So here we have like in triangle ODQ, which you can at least produce the sketch separately, depicting from that figure. Look something like that. This is your O, this is your D, this is your Q. So this side here is 9 and this one is 12, like that. So we are asked here to work up the value of the length of a chord. So the length of a chord is NQ. So it's just like, how long is N to Q? Right. So now, based on what we have discussed, to find the distance from N to Q, that represents the length of a chord, you'll be able to realize that, say, the distance from N to Q somehow is bisected by the line OD. So which means, in your case, if you'd like to find the distance from N to Q, firstly, just find the distance from here up to that, which is as good as working out from D to Q in this case by using this triangle. So once you have found this one, what do? You know that this distance OD is the same as distance from D to N. Then what you do to find it, just say N to Q, just multiply the value of this length here times 2. Then you have got the distance from N to what? To Q, that is the length of your chord. Right, so here, how do you get that one? The same story to say by Pythagoras theorem. It's a right angle triangle. The square on the hypotenuse side, which is this one here. You can write it as say 12 squared is equal to this one squared plus this one squared, which is just like your Q D squared plus 9 squared. What do you have this one? 144. What do you get there? Q D squared plus what? 81. Let them together. This comes to this side. You have got 144 minus 81, which is equal to what? QD squared. Right. From there, where do we go? Just simple. Right. This minus this gives us what? 63. And this is the value of what? QD squared. Now, to find the value of QD, in this case, you have to take the square root on both sides. You take the square root of this side and that side. So here, take the square root of QD squared is QD, and square root of that one comes in as root over 63. Right. But now, by the demands of the question, they said if you answer in third form, it means you don't have to take the square root of this one directly by producing the decimal numbers. But what you can do there, what you do is just like if the QD is this, then it means the value of chord NQ, chord NQ, NQ, which is your chord in this case NQ, should be equal to 2 times the square root of what? 63. Because square root of 63 is just part of here, of NQ. So this is root of 63. Right. So, as mathematicians, you have, suppose I simplify a particular expression as such, if it is possible. Like when I multiply this by this, I'll still get 2 root of 63. By what we have discussed in the irrational numbers in the previous video, if you can follow, you were always requested to at least do what? Simplify the start to the simplest form. So what I expect you to do is, you cannot leave your answer like this one. Yes, it is in side form, but you have to come up with a simplified side form. So what you do here, based on what we discussed in those videos, you'll be able to see that we discussed that, say, you need to take 2 factors of the number in the root. One should be the rational factor, another one should be a perfect number. So in 63, we have got 9, a perfect square in this case, multiplied by 7, which regards as like what? A rational number, which is just like a rational factor. So when I split the 63 into 9 by 7, it means in that case, if you like to simplify the terms inside, which are factors, I'll be in the position to have the square root of 9 as 3, which will be outside here, meeting with the 2, and the 2 they're going to multiply. But the square root of 7, I will not have it. That one is irrational. So it means I'll leave this one as root of 7. So it means the final answer should be 2 times 3. I get a 6, root of what? A 7, like that. So this one should be in centimeters, if anything. Right, so you have the, therefore, the chord, easy, you get it that way. 6 root of 7 centimeters. So this is the way you can use that knowledge about the first property of a chord. Right, see, that's very easy. So additionally, what you can have here, I think what you can see here, what is more paramount is the knowledge about the Pythagoras theorem, which will be studying with it now and again until the end. Because everything we discuss here is about the triangle as such. All right, by this we end our discussion in this video. But before I go, let me just give you an exercise which you can just write at your own time to test yourself that maybe you've got something or not. Right. In my exercising, I will not write all the statements down here. I'll just explain. I'll need you just to work out on the following. You are given a circle like this one, and listen to me attentively. O is the center, and you have got a chord. The first one is this one here, and the other one is this chord here. The second chord is X, Y. The other one is called A, B. Look at that. And here the center O, right? And the line starting from the center, it is going down here and it is joining N at this point here. Right. We are told that say chord A, B is parallel to chord X, Y. Right. And there's a line from O to B, and this one is given as 15 centimeters. And also we have side Q, M is equal to X, N. This is M. Look at that. And this one is given as 9 centimeters. The question is simply asking you to find A, the length of AB. How long is A to B? Given this information here. And again, number B, find the length of MN. How long is M to N? M to N. This line, this section here. Right. So remember, this is 15 centimeters. And we have got that's the QM. Talk of the OM, not QM, but now OM. We don't have the Q here. Talk of OM. OM is equal to XN. I have to go through that one. XN. XN, XN, or say NX. Right. And the value of which is 9. Find AB distant from here up that longer chord, and also MN. Right. So if you can take your time, you solve those ones out and find out the solution to which, then things I think are better and we are moving together. Thank you very much for this. So I always still more encourage you, ladies and gentlemen, for the part of the mature, and also boys and girls, to always update yourself by having a back play of the videos in the link down here, so that every time we meet, we have to be connected, because the new concept that we discuss will always be referred from the previous videos. Thank you very much for being together.